Hello, everyone. Welcome back to our Journey into Tech series. My name is Chanel Power. I'm the founder and executive director here at Mentor Me Collective. So I'm super excited to see all of you here. If you are somewhere in the world, I want you to let us know where you are, which I know you are. Drop some fire emojis in the chat if you are excited, because Lord knows I am too. We have an amazing, incredible guest today, and I'll share a little bit more about our guest in just a moment. But for those of you who are new to Mentor Me Collective and maybe joining us for the first time, I want to say welcome. Mentor Me Collective is a community focused nonprofit organization. We're committed to supporting first generation technologists pursuing careers in technology. We are on a mission to empower first generation technologists with the skills, knowledge, and confidence needed to pursue their passions, achieve their dreams, and positively impact society. We do that through our tech education programs in partnership with Grow with Google. There may be some folks in here that are tuned in and are a part of our scholarship program, so please let us know in the chat. We also have mentorship initiatives in partnership with our corporate professionals, our corporate mentors, and some ERG groups from corporate spaces as well. And we do events like these with champions of the collective tribe, like our wonderful guests today. So if you'd like to learn more, please feel free to visit our website and fill out our contact form. You can just go ahead and go to mentormecollective.org. You can click on contact and let us know what you're interested in or what you need services and help with, and we'll be able to service you. Okay, so before we dive into today's session, I have a few more quick announcements. If you are watching us on LinkedIn and you have not clicked follow, please go ahead and follow us. Subscribe to our LinkedIn page. If you are on YouTube and you are watching us via YouTube, we want to say hello, shout out to our YouTube fam as well. Make sure you guys go ahead and give this video a thumbs up and subscribe to our YouTube channel to stay up to date on all of our events, which we have more coming later on this week. We also want to invite you to join our Slack community. Join our Slack. So I'm actually going to go ahead and drop the link in the chat for you all to go ahead and join us there. Welcome all the peoples. Oh, I love this. We got some folks from Dallas, Houston, Orlando. Okay, Texas. Texas is in here strong. Hey, see, I'm so excited to see you all. Gang, gang, gang. We love it. So, if you want to go ahead and join our Slack community, we have so many different resources in there as well. We definitely invite you all to do the same there as well. All right. So, without further ado, today we are honored to have our amazing Anthony Culver, a senior data engineer at Netflix. He's joining us today with an impressive career and extensive experience in data engineering, and he has contributed significantly to building data driven solutions at some of the world's most recognized tech companies. He'll be sharing his insights on what it takes to succeed as a data engineer, the skills and certifications that you may need or may want to dive into, and how you can navigate this path to a successful career. All right. So, hello, sir. How are you?
Up. Good. How are you?
I'm doing wonderful. Welcome to the stage. Welcome to the stage.
Thank you. Thank you for having me.
Absolutely, absolutely. So I'm not going to take too much time. I'm going to hand it on over to you.
Cool. Hello, everyone. I can see some of the chat. Actually, I think I can see all of the chat. So, uh, feel free to jump in, stop me, call me corny, goofy, whatever. It'll happen. So, um, but as Chanel said, my name is Anthony Culver. I'm going to be talking a little bit about what data engineering is, some of the tools we use, how we go about the process of data engineering, and then I'll drop a few resources as well to kind of help get started. Just things you can do to get started as a data engineer. So um, let's go ahead and get started. Let's see. All right, there we go. So just a little bit about me. Right now, I am a senior data engineer at Netflix. I work in our growth data engineering team, so we support some of everything right now. It's a busy team, fun team. We get to work on a lot of cool stuff. Prior to that, I was a back-end software engineer at Netflix for a couple of years before I joined this team, and then also a software engineer at MailChimp. And then prior to that, I worked as a data engineer for several years in consulting and healthcare technology, several different places. So I've been around for a minute. Um, and then that's just professional stuff, personal stuff. I have a wonderful, incredible family, 3 children. I'm originally from Chicago, currently live outside of Atlanta. Graduated from Clark Atlanta University. Shout out to all HBCUs. I also have a master's from DePaul as well. So, gonna try to get through a lot in a short period of time because I do want to leave some time for questions at the end. But today, the goal is to really just provide some clarity around what data engineering does or what a data engineer does. Some of the tools that we use, just some general clarity because nobody knows what data engineers do, to be honest. So hopefully you walk away with a little bit of clarity there. So kind of broke this up into 4 sections. I'm going to talk about the what, like basically what it means when someone says they're a data engineer. What does that person do? Touch very briefly on why the role exists because I think that's important. And then talk about how data engineers do their job. And then last thing we'll talk about is just some different things and skills that you need to work on in order to become a data engineer. I always like to start setting expectations. Quick disclaimer, everything you're about to hear is just my opinion, right? It's based on my experiences, but I am one person. I always encourage people, go talk to some other people, find more data engineers, find somebody that's going to tell you that everything I said was wrong and they have a completely different perspective. And then you piece together all the information you get in and form your own opinion, your own perspective, and your own viewpoint from there. Other thing I will say is I'm going to try to keep this very high level because there's a lot of stuff to cover. And there may be some people in here who have no frame of reference, no context whatsoever. And I want to make sure that we can get through some of this in a way that they can understand it as well. So I'm going to start with what we do. What exactly does a data engineer do? So when I tell people I'm a data engineer, these are like some of the things that they assume that I do. I'm not a data scientist or an analyst. I'm not a DBA. I don't do any ML engineering. There's way too much statistics involved in that for me. And we're not typically back-end app developers. But the flip side of that is these are all people that we work with. They're either people that are generating data that we consume, consuming data that we produce, or in some cases both. So we do have to understand a little bit about a lot of different things as data engineers. So you have to understand how data scientists and analysts are going to use your data, right? These are primarily the people that are consuming the output, the data that you generate. But even they're using it different ways, right? Your data analysts may be building dashboards and reporting and things like that. Data scientists are digging into the data to try to they're doing research. They're trying to figure out what can we do with this data, right? They're looking at it from a business standpoint, right? Like, what are some things that we can find based on the data that we have, and what are some things we can do with it that we're not doing? ML engineers are kind of working in the same space, but the data that they consume and generate is in a very, very different format than what you see for some of these other folks. And then for the back end app developers, I would say as a data engineer, you have to understand how they think and what their relationship to data is because it's very different. We are often kind of an afterthought in some of the data that app developers are generating. And so you kind of have to understand how they approach data and be able to kind of speak to them and give them requirements in a way that makes sense for them. So this is kind of my standard one-line definition of what data engineering is. So it's really the process of acquiring, cleansing, and structuring data so that we can get it to people at the right time and in the right format that makes sense for them. Like I said, like your backend app developers, your data scientists, your ML engineers, they're all going to consume the exact same data in completely different ways. And as a data engineer, it's your job to understand what those are and to make sure that they have data in the format that works for what they're trying to do. And so looking at that definition, there are kind of six pieces that I'm going to touch on very briefly in this talk. So we're going to talk about what it means to actually get the data and acquire it, clean the data, structure it. Going to talk about what the right people means in this context, what the right time means, and then the right format as well. So, but before we talk about that, let's talk a little bit about why this role exists. A lot of times, I've run into a lot of people that would argue we don't need data engineers. I've seen people write whole articles about it and talk about how data engineers are a bottleneck and we don't need them because we have X, Y, and Z tools. And now it's going to turn into, oh, we have AI. We don't need data engineers anymore. Like it's going to be a thing. But um, really, data engineers exist because there were new problems that arose. I always go back to not the first iPhone, but the second iPhone when they first released the App Store. That, in my opinion, shifted everything in terms of software development and how we deal with data and what our relationship to data is as technologists. So before that, you had to sit down at a desk, at a computer with a laptop or whatever, and then you got on the internet, right? You weren't traveling around with it. It was a very intentional thing that you did. And you were not generating as much data as we generate now. And so then now you have this little device in your pocket that is on 24/7 connected to the internet, and you can do almost anything you want to do, right? And so that shifted things, right? So now you have your infrastructure folks that have to now figure out how they're going to store and process and handle all of this additional data. You have your front end engineers and your UX designers that now have a completely different entry point to your app, and they have to deal with all of this stuff, right? Same thing with the backend app developers. They have to figure out how to handle the scale of all these additional people being able to access your app at any time, right? And so there are all these things that they have to figure out, and we still needed somebody to deal with this data, right? So in comes this role of data engineers where you figure out how to collect the data, store the data, serve the data, and kind of let those other folks deal with the things that they need to deal with, right? So there was no existing role. We definitely want to keep the separation of concerns between the engineering teams, but also having everyone stay within their domain of knowledge, their specialization allows you to move quicker. And then also with fewer things to focus on, data engineers can also focus a little bit more on data quality. Although my argument there is that is everyone's responsibility. We'll talk about that later. All right. So now I'm going to talk about how data engineers do their job. This is where we get into a lot of stuff. So I'm going to go back to those 6 points I brought up in the initial definition of data engineering. And I'm not going to go into a lot of detail on all of these. I'll share these slides out. I have some slides in here that have a lot more detail if you're interested. But for purposes of this conversation, I'm going to keep it a bit high level here. So getting the data is first step. And this can be a little chaotic at times. Just really depends on where you're getting the data from, right? But it could be anywhere. So if you're dealing with more structured financial data, right? A lot of these larger enterprise financial systems will just generate a report at the end of the day, say, here's everything that happened today, throw it in a file, and you do what you want with it. Very, very common thing that happens at a lot of bigger companies. You could be Another common pattern is querying data from a database. It could be an application database or some other like replicated copy of the data. This is also another really common pattern. Excuse me. So typically those are the primary two. Another one is you could have to query an API, right? Some services out there you need to use that to get data. Um, that's something that also is not uncommon. Or you could possibly need to scrape some data from a web page, right? That's not ideal. That's not what you want to be doing, but sometimes you don't have a choice. So there are all these different ways and methods you have to know of how to get the data. And as a data engineer, you need to be able to do all those things and you need to be able to do them all efficiently. So you do have to be good with SQL. You do have to write code. You're not going to get away from that. Sorry if that's what you thought was going to happen, but it's not. Um, so that's step one. Step two would be cleaning the data or even transforming the data. Um, yes, it says all data is trash. I'm a firm believer in that. I assume every data, like every data set I work with, is bad. There's something in there. I may not have found it yet, but there's something in there that's going to go wrong at some point. Um, and so you have, as a data engineer, you have to be aware of those things. You have to look out for those things. So again, we talked about all the different sources where you can get the data. Some of that data is just user generated, right? So if you think about people typing something in, people using emojis, right? That could break a lot of things. Or, dealing with different languages. People might type in multiple languages in a single text or a single message or something like that. And then how do you deal with that, right? It could be typing in English, which is a left to right language, and then maybe another right to left language, right? You might have all of that together. What do you do with that data? And then there are other things that are always issues, challenges. Dates are a nightmare to deal with. Are they stored numerically? Are they stored in some regional or local format? Right? Like outside the US, you might have a date structured in day, month, year. We might do month, day, year, right? If those two are mixed and there's no consistency in how the data is generated, then you have a mess, right? Because how do you tell the difference between January 2nd and February 1st, right? You don't know. There's no way to figure that out. So structuring the data, I'm going to come back to because that is one area I'm going to focus on a little bit. I'm going to go down to this bottom section, right? So the right people. Data security, data privacy is very important. It's always been important, but it's a lot more important now because governments are starting to regulate that a little bit more. So GDPR, if anyone's heard of it, if you haven't, it is the I don't remember the acronym, General Data Protection Regulation. Somebody in the chat knows. See, I see you in the chat. I know you know. Um, but basically, it's a set of laws that are intentionally vague, and they are designed to protect the data privacy of citizens of the EU. Some states in the US are starting to crack down on that a little bit more as well, but something we should always think about. And as a data engineer, you're moving data around from place to place. You need to make sure that you are only giving access to the people that need access to that data. When we talk about the right time, we typically talk about refreshing data in real time versus batch. And really what that means, batch processing just means that there's data refreshed on some sort of regular cadence. It's very common for this to happen daily. Could happen hourly, could happen every 15 minutes, it could happen monthly, weekly, quarterly, yearly. Just depends on what the needs are. Pretty standard, much easier to deal with than anything happening in real time. Real time just means the data is available and has been processed almost as soon as it is generated. Um, I can tell you from experience, this is almost never necessary. Um, People will ask for it. There are cases where it's necessary, like if you have a gaming platform, for example, and you're keeping track of scores on a leaderboard, that is something where you need real time data processing and you need to make sure it's correct. A lot of times, I've had situations where somebody says, "Oh, I need this data in real time." My first question is always, "How often are you going to use this data or query this data?" Maybe, "Oh, every 3 hours." Like, okay, well, you don't need a real time pipeline. Well, we need the data refreshed. Okay, we'll make that happen, but it doesn't need to happen in real time. So you have batch processing, but it can be smaller batches, and that's usually a little more ideal, definitely easier to manage. Um, and then the right format. Talk about this a little bit later, but um, there are lots of different types of data stores now, and the amount of data, the way your data is being queried, how quickly the data is being updated, all of these things matter. And part of a data engineer's job is making that decision and saying, okay, I have this data set and it's going to be used for reporting by this person. I need this type of data store. It's going to be used by this application. So they need very low latency queries. It needs to be in this kind of data store. And then once you make that decision, then we get to the structuring part. And that's what I want to focus on a little bit in detail here. Because this, we're going to start talking about data modeling. And this is what, in my opinion, is the most important thing that data engineers do. We do a lot of work just kind of getting data, cleaning it up, doing transformations, generating metrics, getting it out there, managing like access and all these other things. But a bad data model will break everything that you're doing. And this is the number one thing that I've seen cause so many problems. Um, and it's really important, and I don't feel like it gets talked about or focused on enough. So, I'm going to talk about this a little bit more. Okay, these are actually slides I was going to skip. Anyway, this is what I wanted to talk about. So, when we talk about data modeling, the most important thing I think to keep in mind is that everything has a schema. Schema is just the defined structure or the agreed upon contract of what this data is supposed to look like. And a while back when NoSQL databases first became a thing, MongoDB was the big one. And all the application developers were so excited because they were like, yes, I don't have to have a schema anymore. I can do whatever I want. And then they just started throwing data just chaotically into MongoDB. And what happened was it ended up very badly, right? Because there is still a schema. You still have to have some structure to your data. I think the thing that it took a while for people to understand is that NoSQL databases, you can modify the schema. The schema is dynamic. You can change it without, having a huge process to do that. But there is still a schema, and there's still a reason that it has to be defined and agreed upon, and everyone kind of is on the same page about that. But I think those first three pretty straightforward and standard to understand that relational databases, NoSQL databases, OLAP, which is online analytical processing. Those are for like basically reporting environments where you have a lot of data and you need to aggregate it and build reports and things like that. Those three pretty much everyone thinks about in terms of having schemas to some extent. But then there's also documents, right? Like HTML, Markdown. Those are documents, right? And they have schemas. If you don't think they do, go ahead and try to do some web scraping. Then you will understand that HTML documents have schemas, right? And then there's JSON, XML. System logs is another interesting one because these are usually generated by another application, and they typically do have a very fixed schema, right? There's usually they're usually separated by tabs or spaces, but there are very specific columns or data points, right, that are there in those system logs, and it's pretty structured and pretty consistent. Uh, Normally, there's some times where that goes off the rails too. So I want to walk through a really, really simple example of why the data model is so important, and how it can vary based on who's using it. So this is a very simple example. Let's say this is a user profile that is stored in some sort of web app, right? And so web apps are typically dealing with data that kind of looks like this to some extent, right? It might be JSON, it might be some sort of struct or some other format, but typically it's something like this. So we have like some sort of generated ID, status, name, and then I have a list of email addresses, right? And so I have multiple email addresses. There's one is my work, one is home, and then a flag to indicate which one is my primary email address, right? So this is pretty straightforward, right? And this is what application developers are typically working with. As a data engineer, if you're consuming data from an application, it might look something like this. And this is what you start with. This is an example of something you might store in like a document database. So think MongoDB, DynamoDB, something like that, where you might have a key, which is your ID, and you look up this entire object, right? It's good for profile data because you have a single key, you're always reading and writing the entire object. So then let's say a couple months later, got this app running, and now we need to report on this data in the data warehouse. So you look at this first example, this looks very, very different from that. There's some new things there that weren't in the previous object. But if you look at the data that was there, you see, before it was just one object, right? And now I have two records here. Um, for anyone that's familiar with data warehousing, data modeling, this is a slowly changing dimension, one of the several variations of slowly changing dimensions. And all that means is there's data that we want to keep track of when it changes, but it doesn't change often. And in a lot of cases, the time range of when that data was in that particular state matters. So this is one of those situations where, say, we care about when I change my primary email address. You see these records, you don't have both email addresses in both records like you do here, but we only keep the one that's flagged as primary. And then you see these effective start dates and end dates. Those really indicate when that change happened. So something else you might see in another form of this is like an active flag, something that says like yes or no or one or zero. But you can use that to query this data based on the time range. Perfect example of this is sales data. If you want to report on sales data for each individuals by like over the course of a year, but you want to attribute it to their department, right? But say somebody changed departments in the middle of the year, you want to make sure that the sales that they accrued in that time period get attributed to the correct team. This is the way you do that. So this is something as a data engineer, again, you have to understand what your downstream consumers are doing. You have to know that they care about that, right? And so if you know that they care about that, that informs the way you model this data. So you would build something like a slowly changing dimension as opposed to just overwriting the current data, right? Then if you get down to this next one, again, I told you I don't do ML stuff, so I'm not going too deep into this, but um, machine learning models consume data in a different way. So this is a very, very trivial example. So let's say somebody's working on a machine learning model and they want to be able to predict somebody's first name based on their email provider, because that makes a lot of sense, right? Um, so what you would do is maybe have like break this out and say like Yahoo, Gmail, Hotmail, hey.com, whatever. All those providers are different columns or different fields or different inputs. And then you just have like a one or zero flag. And this is because machine learning models typically operate better or sometimes require data to be in numeric form. So even like the status code over there on the end, we change those statuses to just a numeric value, just some sort of numeric representation. And that goes into your ML model input. I'm not going beyond that because this is outside my wheelhouse. But again, as a data engineer, you have to know a little bit about a lot of different things. And I understand enough about this to know that this is a thing that I should be considering if I'm building a data set that's going to be used by a machine learning model. So it's another thing I'm not going to really go into detail on this, but what I'm going to do is jump into the last section here, talking about like what you need to do, the skills you need to have as a data engineer. So I'm going to start with the must-haves. These first three are if you don't learn anything else, if you're not good and you don't master anything else as a data engineer, you have to have these three things. First one is coding. You're not gonna. I mentioned it earlier. You're not gonna get away from that as a data engineer. I know a lot of people hate writing code. Perfectly understandable. And there are definitely roles with their specializations within software engineering where you don't have to write as much code. To be quite honest, data engineering is one of those. You're still going to write some code, but it's not going to be to the same extent as if you were doing like some distributed software engineering or something like that. But again, you have to learn how to code. You're not going to get through the interview process if you don't know how to code. If you don't already know a programming language and you want to start learning one, absolutely start with Python. Everything in the data space is very, very Python centric right now. If you do already know another language, that's fine. Still get a little familiar with Python, but that process will be a little bit easier if you already know how to code in another language. You also need to know some advanced SQL concepts. So if you've ever had to query a database, you are probably already familiar with your basic select from, where you may have done some like group by and aggregations and stuff like that. As a data engineer, you're doing a lot of that, but you're doing a lot more of these advanced things as well. Um, so understanding different join types. If you may not even know there are different join types, right? You have inner joints, you have outer joints, you have cross joints, right? Like in some cases, you have left joints, anti joints, or all these other things. You need to understand those and understand them very well. Not necessarily to be a master of all those things, but knowing that they exist and knowing when and how to use them, right? I might have to go look up the syntax for something, but I know that like in this particular scenario, what I need to do is a left anti-join. Can I do that in this database? Um, and I might need to go look up specific syntax, but that's fine. I know that I need to do that. Window functions. I have mixed feelings about this. I think they're important. I'll be honest, before I started at Netflix, I used a window function maybe once my entire career. But I use them every day now, almost every day. So it really just kind of depends on where you are and what the need is, but it's a thing that you still need to know how to do. And again, knowing that it exists, knowing when to use it, maybe you have to go look up the syntax. That's fine, but understanding the tools that you have available to you. Then common table expressions, um, basically kind of writing little subqueries that you use later in your main query. That's in some cases it's necessary. Some cases it's just a kind of a performance optimization. That's another thing you need to do is just understanding how to make your queries more performant when they get slow. Um, Data modeling, just talked a little bit about that. Like I said, I think it's the most important thing you can do as a data engineer. Um, and a lot of that is knowing the difference between the different types of data stores, knowing when to use them and what scenarios they're going to be more optimal than others. So in the application example, application databases need to be very low latency. They need to be fast. So using an analytical database is not really going to work for that, right? Because if you, I don't know, you log into Spotify and you need to go to your profile and your profile data is stored in a data warehouse, you don't want to sit there and wait 5 minutes for your data to come back. You're not even going to wait 5 seconds, right? So understanding that that's the scenario that that data is going to be used and modeling your data appropriately is super, super important. Um, Advanced concepts. So, two things that I think are kind of like next steps that are, again, really important, but also very, very advanced. You're really getting into the weeds technically here. So, data processing frameworks. A lot of people, when they're starting out, they're writing Python. They use a library called pandas, and like that's what people use, right? And read some data in. I can play around with it, do some stuff, make some charts or whatever, right? That's cool. But then when you get to the point where you have to process, I don't know, 5 billion rows of data, probably can't do that on your laptop, right? Um, so that's when you get into some of these data processing frameworks. These are things like DBT. DBT is very, very popular right now. I don't use it, but it's gotten popular enough that I'm going to start learning it just to kind of keep up with it and be a little bit more familiar with it. What I use in my day to day is typically Apache Spark. That is kind of like the de facto standard tool that you use for processing, for doing distributed processing of large quantities of data. There are other tools available that do the same thing. There's Apache Beam, there's Apache Flink, there's several other tools available. Spark has kind of grown in popularity and almost become like the default that everybody expects that you know. It is a lot to try to learn, especially if you're starting out. So this is why I say this is an advanced concept. Get those other things down first before you get into all of this. And then distributed systems. I don't really hear this being talked about a lot, but understanding just generally how distributed systems work is important because almost everything we deal with in big data world is a distributed system. So you're maybe consuming data from uh, another tool called Apache Kafka, right? This is more like event streaming, more like real time stuff, but that's a distributed system, and you have to understand what that means because the way you build your tools and your pipelines to consume that data matters when you're dealing with distributed data. Same thing with like some of the NoSQL data stores, a lot of the analytical data stores, they're all distributed systems, and you need to understand the fundamentals of how those work. Also, when you go into the interview process, you're probably going to get a system design interview. This is going to come in handy there as well. And then just kind of going beyond the core skills, I wouldn't necessarily say these are advanced concepts. I would argue that data quality should be one of the non-negotiable things that you start with, but just being completely honest, data quality is a thing that gets overlooked in most places. Um, but it's still a thing that you should be familiar with. You should always be thinking about it. Because we could spend a week talking about data quality. But it's a lot of resources out there to go and just kind of read about it, see what the best practices are, how to identify data quality issues, and then more importantly, what to do when you find them, right? Do you just ignore the data? Do you alert somebody? Do you store it somewhere else and have somebody look at it later? There are a lot of different ways you can handle that. Data pipeline orchestration, something to be familiar with. Say, for example, you have three different data pipelines that read three different tables, but one of them has a dependency on the first two being available first, right? Then you get into the situation where you have to manage dependencies. You have to kind of manage these a larger workflow, right? And there are tools like Apache Airflow is a really common one. I feel like everybody hates Airflow right now, but like it's kind of a necessary evil. But a lot of people do use it. There are a lot of different tools out there. I always give Airflow a lot of credit, but it does its job really well. And it's grown a lot. There's a pretty big community of folks that support it and maintain it as well. So, but something that does data pipeline orchestration, you might have to write something yourself, right? And that's okay. It's not ideal, but just knowing the fact that that's a thing you have to consider when you're building data pipelines and managing dependencies. And then the last thing over here is software engineering best practices. Excuse me. This is something that I think is important that a lot of data engineers kind of gloss over because most people don't consider us to be software engineers, right? And data engineering is just a specialization of software engineering. And we are writing code. Like we're software engineers. We have to still have good practices in terms of like how we manage our workflow, how we manage our code, how we deploy our code, right? Like all of that stuff matters. It just looks different because we're not deploying, a React app, or we're not deploying a Spring Boot service. We're deploying a data pipeline, but we still need to follow the same processes. That helps with a lot of things. It helps cut down on bugs. It helps cut down on, human error, a lot of other things, right? So just something to keep in mind. All right. Excuse me. Last couple of things I want to talk about, certifications. So I have some mixed feelings about certifications. I think this is a topic that's more relevant for people trying to come into tech from other fields and other backgrounds. And I see this a lot where people are just like, what certifications can I get? I need to get certifications. They go out and they get all these random certifications and they are completely irrelevant. And I think part of that is there's a lot of people just putting bad information out there because they want to get likes and they want people to come follow them and pay for their courses or whatever they're doing, right? There's a lot of that out there. But the thing to keep in mind is that technical certifications in like the software engineering field, they don't work the way they do in other fields. I would say network and cybersecurity certifications are kind of exceptions because those are a little bit more important and those kind of matter. You almost kind of have to have those certifications to get into those fields, right? But if you go somewhere and like, let's say you want to become a registered nurse, right? Or even not even that, just a certified nursing assistant, right? There's a process you have to go through. When you're done with this process, you have to go and there's practical work that you have to do. And then you pass an exam and then you're certified, right? And that certification means you can go and work and do this job. Tech certifications don't work like that. Some of them may, but it just depends. It's a mixed bag. I can tell you from personal experience, I have passed certification exams and I have never used the product before. So that's the thing to keep in mind. Now, what I will say is that certifications are not bad. I'm not saying don't do them. And I'm not saying that they're worthless. I use certification prep, for example, whenever I want to learn about a new thing. That is the first place I go. Do they have a certification program? Let me see the certification prep checklist. And I use that as my study guide. And that's what I go through to learn a new technology because it's going to be comprehensive. It's not going to be thorough and detailed, but it's going to cover everything that you can do with that tool, everything that that vendor, that product deems important. So you'll actually learn those things. Then you have it's on you to go and actually use it and build those things. Whether or not you take the exam is up to you. I typically don't anymore, but I'm old and I got a lot of work experience, so it's a little bit less relevant on my resume to have those. But another thing about the certifications, if you do go ahead and take the certification exam, it's also a great way to get the attention of recruiters, which is really important right now because the job market is just a nightmare right now. So anything you can do to give yourself a leg up and get the attention of recruiters is always going to be beneficial. And a lot of times what recruiters are looking for is just whatever the hiring manager told them, right? So the hiring manager says, I need somebody that has AWS Redshift experience. You may not necessarily have a lot of practical experience or any practical experience, but they're going out searching for keywords, right? And they see you have a certification and then you have AWS Redshift on your resume, and that's going to flag your profile for them. And that's when you get reached out to, right? Because that's the thing with the job hunting process is you're trying to get people's attention. You're trying to get the attention of somebody to actually talk to you, a human being to talk to you, and then you're trying to get to the point where you can get in front of somebody and show them that you're capable of doing the work. You don't necessarily have had to do it at a Netflix, a Google, a Facebook, but if you understand the concepts, if you can get in front of a person and talk to them about that and show them that you understand those things, that's what you're looking for. So certifications are a good way to do that. In terms of data engineering certifications, there aren't a ton of them. There are some vendor specific ones. So for specific products like DBT, I know has one. Snowflake is another platform that has certifications. Cloud certifications are really good because you're going to have to interact with cloud platforms at some point. So AWS, GCP, and I believe Azure all have data engineering certifications. So they are going to test you on very common, data engineering concepts, but they're going to be specific to that cloud provider. Um, I will say, obviously, AWS is the most popular, so people tend to go with that. Azure is pretty popular in terms of like mid-sized companies and some of the bigger enterprises as well. And then GCP, I just have a special place in my heart for GCP. I love Google Cloud. Um, I enjoy working with Google Cloud more so than the other ones, but it's not the most common out of the three. Um, and then different learning platforms have certifications. These aren't really like formal certifications. Um, it's more of a kind of like a badge you can put on your LinkedIn profile to say, I went through a whole course about this thing. I actually did some work and built some practical projects, and this learning platform has certified that I've done that. But those are also good to do. Anytime you can get practice building something, it is good. It doesn't matter what form it's in. Whether you're doing certifications or just doing the work, putting it out on GitHub, writing blog posts about it, whatever. So key thing is just practice and build. So I'm getting towards the end here. I want to try to wrap up and leave some time for questions, but a few resources for learning. I always tell people start with free things. You getting into this field, anybody can do it, but not everybody enjoys it. And you need to actually know that it's something you enjoy doing before you invest a whole lot of time and especially money into it. So I always tell people start with free resources. Free Code Camp is a great one, especially if you need to learn how to code first. There's a lot of they have some good Python learning programs on there. They have I think a couple Python certification programs as well. They also have some stuff on like shell scripting, SQL, a few other things that are useful. So definitely check that out. I have a ton of other resources. I put together this doc a couple years ago, which needs a little updating, but I will share that when this gets shared out as well. That doc has a ton of resources. It's mostly centered around interviewing for data engineering roles, but there's a lot of stuff in there to help learn some of these core skills as well. Two books I want to call out: Data Warehouse Toolkit. It's a very old book. It's somewhat outdated in some cases, but this is like the Bible for data modeling and data engineers. So Ralph Kimball came up with the first, like the most commonly used data modeling pattern um, for data warehousing, and it's still used today. There's still so much in this book that is relevant. Absolutely start with that. Designing data intensive applications. I'm always preaching about this book. It is my favorite technical resource that I've ever encountered. I feel like it's required reading for every software engineer, no matter what discipline you're in. It talks a lot about the different components of building these like data centric applications, and so it's relevant to everyone that's working in this field. It's very well written, very approachable, easy to consume. Definitely check that out. And then the last thing, got to build things. All of this like I said, anybody can do this work, but it takes practice. It takes time. You have to it's just time and repetition. You have to build things. You have to keep building that muscle. Um, but for data engineering, what was cool about this is like it's very easy to stay motivated because you can always find a topic or subject that you're interested in, and ask a question about it, and then go look for a public data set somewhere and start playing around with that data. Build data pipelines, do some analysis, do some data cleansing, write it to another table, build some dashboards and stuff on top of it. I did this a couple years ago with COVID data that was published by the New York Times. I was trying to learn something a little bit different, but I used that kind of as a starting point. I was trying to see if I could correlate like things that were happening in social media with spikes in COVID cases, right? So there's all kind of stuff you could do. A million public data sets out there. Google Cloud has a lot. There's a GitHub repository called Awesome Public Data Sets. Just links out to a bunch of different public data sets. Also, news media outlets tend to publish their data on GitHub, actually. And this is a great place to get some practice with data engineering because all of their data is absolute trash. It's great that it's there, it's available to you, but they make no effort to clean it up. It's just this is the dump of the raw data we got. So it's an excellent way to get practice dealing with dirty data, having to clean it up, having to think about data quality. So definitely check those out as well. So yeah, in summary, data engineering is just a specialization of software engineering. Only difference is we're not building React apps. We're not doing like backend software engineering or ML engineering. We focus on challenges around movement and curation of data. That's it. So that's all I have for you. Thank you for listening to me ramble for almost an hour. Feel free to hit me up on social media, LinkedIn. I'm always happy to chat. And I'll share all this out later as well. So thank you.
Absolutely. Thank you, Anthony. This was such an amazing presentation. I do want you all to just go ahead and screenshot this. Definitely follow him on all of his socials, especially X. He is hilarious on X. Uh, with super cool tweets about family, kids, and just life. But yeah, so we're gonna go ahead and lean into Q&A. I did see some awesome questions come into the chat, so I'm gonna go ahead and highlight one. So from Victoria, as someone without a degree, what are the best routes to take to land an entry level job in data engineering?
Yeah, it's a good question and very interesting one. I've been thinking about this a lot recently because it is actually very hard to find entry level roles in data engineering. It's really hard to create space for that in certain environments. I've had conversations with folks at Netflix on my team at some point as well, and just trying to figure out like if we brought someone in that had very little experience, not necessarily like could we handle it, but will we be setting them up for success? And that's what you don't want to do. You don't want to bring somebody in with good intentions and then you're not able to really support them, right? So What I would say is, one, you have to start with the companies that you're looking at, right? Um, there are some of the bigger tech companies have like programs specifically dedicated to people transitioning from other roles, people coming from different industries, people without degrees, and in a lot of cases, like new grads, people just graduating from college degree programs. So that's one thing to look for. Another thing I would say is, outside of those specific programs, focus on smaller companies, right? Don't Everybody wants to go with the big flashy tech companies, even small tech companies. Like, go to your traditional corporate environments, go to some of your like smaller companies. And the reason I say that is, you get to a Google, a Facebook, a Netflix, the amount of data we have to deal with necessitates you having a lot of experience in a lot of other things. And so smaller companies that don't have as much data to process, they're not using a lot of the same kind of tools that we're using. They're not dealing with a lot of those same challenges. And it's much, much easier for them to bring in somebody with less experience. So I know it's not a great answer because, like I said, this is one of those really weird kind of hybrid roles where a lot of people that have been in this role for a while, they just ended up in this role, right? Somebody just dumped a problem on them and they had to figure it out. And then 10 years later, it's called data engineering, right? That's how I ended up in it, to some extent. But but yeah, I know it's not a great answer, but that's what I would suggest.
I think that was an awesome answer, and it was very practical as well. I think you already highlighted this, but I'm just going to bring this up again. A LinkedIn user asked, "Is there a learning platform that you recommend for practicing technical interview questions specific for data engineering?"
There are a lot. um I will say, the kind of typical ones, you have Leak Code. Like, Leak Code has a lot of SQL problems you can practice. HackerRank has some good ones. I use HackerRank just to kind of practice some of that stuff. There's several other like smaller ones, but yeah, it's really like the coding stuff. You still have to do that, right? The Leak Code style problems, SQL, and then just like data analysis. Excuse me. So I think that's one of the things that's a little bit harder to practice. Um, I can tell you from interviews that I've done, one of the big things that I see people missing, or just kind of not doing, is going beyond what you see in front of you, right? So in an interview, somebody might just put a query in front of you with no context whatsoever and say, tell me what this query is doing, right? So you have to be able to look at this and say, like, oh, okay, I see these calculations, and based on the field names, this is probably what this metric represents. But then taking that a step further and saying what it means to the business, right? Like, always focus on the business. Think about what the business problem is and how it's relevant, right? So doing that kind of stuff, and then making inferences about the data. So if you see this query is coming from a table called, I don't know, sales monthly ag, right? You can assume there's probably a sales daily aggregation or maybe a sales quarterly aggregation. And if you see a problem where they're trying to like maybe do an average of an average, say, okay, this is already aggregated. Maybe there's a lower level table I can use, or maybe there's a higher level aggregate that just already has that information, right? So thinking beyond like what's right in front of you. And that's where I think some of that practice of going to like open data sets and things that you're interested in and asking yourself questions and trying to figure out how to answer those questions with the data. That's where I think you can get a little bit more of that practice. Um, Other thing I would also say, networking. There are a lot of communities out there for just people in tech in general, people in software engineering, but also some data engineering community. So there's a data engineer in Netflix who started a community called Data Engineering Things. That's one you could join. There's the Seattle Data Guy, is a pretty active like Discord group, and he's always posting a lot of information. So joining those communities, seeing what other people are doing, but also asking people if they'll do mock interviews with you. Right, that's another good way to practice as well.
Excellent. I'm learning even some things on my own too. I love that. So Alyssa's next question: any recommendations or suggestions on a good place or way to start building up your data modeling muscle or knowledge?
Yep, I'm gonna keep repeating myself. Go. finding your own data sets and playing around with those and trying to answer those questions, right? Because what'll happen is, let's say you figure out something that you want to do, you build a data pipeline and you write some data somewhere, then you start trying to query that data and it's really slow, right? It's probably something wrong with your data model. And then you have to figure out why it's slow, right? Then you start getting into this is where you get into the technical details, right? You start talking about things like explain plans, right? An explain plan basically is just a list of like steps that the query engine took to get your data, and its way of trying to optimize that and make it as fast or efficient as possible. So I eventually, like over time with practice and things, you learn how to read those and see, oh, okay, this thing happened here. I need to go like put an index on this field in this table, or I need to partition this by something different, right? So that's how you start getting into some of that. I'll also I have a link to I can't remember this guy's name, but he's got a YouTube channel and he has a lot of like end-to-end data engineering projects that you can do. And then when I say end-to-end, it's like, here's a data set, you're going to do X, Y, and Z. You might actually use Airflow to like do some orchestration. You write the data and you build like some sort of dashboard on top of it. Those kind of things will help you kind of get an idea of what to do, but they're also just good projects to do as well. I cannot remember his name, but I will find that and I will add that to these slides before I share them out.
Absolutely. All right. Next question from William. Hi, William. How do you feel about data engineering job descriptions having many technologies as required? Every company is different, so the tech stack changes often, and it's hard to know them all. Great question.
It is actually impossible to know them all. The first thing I'll say, just as a general rule, don't ever let the requirements of a job description discourage you from applying. In how long has it been? 17, 18 years of working. I've had maybe one job that I was qualified for based on the job description, right? Like, you're not going to check all those boxes and they don't expect you to check all those boxes. Now, the flip side of that is, like I said earlier, as a data engineer, you have to know a little bit about a lot of different things. And in some cases, it's a lot of different technologies. Um, and what I will say is, I haven't used all of them, but when there's something that I haven't used before and I don't know anything about, I just go read about it, right? I don't have to be an expert on it. I don't have to have any practical experience with it, but it's something else that kind of I can keep in the back of my mind that I know is in the toolbox in case I need it, right? Perfect example, several years ago, back when I was consulting, I hadn't really worked with any NoSQL databases before. I knew what they were, I knew how they worked, and I knew what several of the options were, right? I read a little bit about like MongoDB, DynamoDB, some of the other cloud-based ones, Apache Cassandra, Apache HBase. Um, there are a million different ones, right? I hadn't used any of them, but I read about them and I knew enough about them to say, like, I'm going into a project, this is probably going to be the most ideal solution for this. Then I go and start kind of playing around with it and learning and getting that practical experience, right? So it's just knowing enough about a technology to know when, where, and how it's best used. And then when you actually need to use it, then you go and start learning, and then you go and start practicing. But in terms of job descriptions, like, they're gonna put everything on there. Like, nobody there knows everything. Perfect example, the team I'm on now, we deal with a lot of streaming data pipelines, in addition to batch pipelines, right? We use Flink mostly for our streaming data. I don't have any experience with Flink. I had no experience with Flink before coming to this team, right? I have experience with Spark. I have experience with like other stream processing tools. And so, like, conceptually, they work the same, right? There's a lot of nuance there, but in terms of the difference between them and like what they're well suited for, but the general concepts of like how to build and manage a streaming data pipeline are things I've done before, right? So that I don't focus too much on the technologies in the job descriptions. I focus on like why they're using that technology, right? If they're using Apache Flink for something, it's because they're doing stream processing, most likely. Are they actually using Flink? Maybe, maybe not. But I can go in an interview and I can talk about what you need to do, things you need to consider when you build a streaming data pipeline. So I don't know Flink, but I'll figure it out, right? Like those are the things that you have to be confident in the skills that you have and the things that you've learned, more so than the technologies that you're familiar with.
That was good. I love that, honey. Reverse engineering. Our last question for the night comes from Evans. How do you ensure the scalability and reliability of data pipelines in a rapidly growing environment while balancing the needs of real time processing and batch workflows?
I don't have a good answer for that. I will say it's hard, and it's a hard job, right? Like that's what we get paid to do. We get paid to solve the hard problems, and this is one of those hard problems. What I will say is that like starting small and starting simple is usually something that is helpful, because the stakes are much lower, right? Let's say you have to consume. Let's say you have real time data pipelines, and let's say you have to consume 10 different sources, right? Start with the one that is the least critical, the one that has the lowest volume, lowest velocity of data, and start there. Get everything working, try to break it, see what falls over, and put all of those things in place that you need to monitor that pipeline, right? It's one thing I probably should have mentioned that I didn't touch on in this talk was like data observability, right? Like knowing when things are going bad, and being able to handle that and recover from it gracefully. Having fallback plans in place, recovery strategies. How are you going to backfill data if you need to? If there's some sort of data issue, all of that stuff. Think about that as early as possible, because what you don't want to happen is wait until you're ingesting 6 million events per second and then something goes wrong and you're like, oh, we got to figure out how to fix this, right? You want to have a plan in place before you get to that point. So that's the best answer I can give you on that.
I think that was awesome. And I am so excited to have the opportunity to share your wonderful wisdom with our community. So drop in the chat some fire emojis if you enjoyed Anthony's chat today. As for mentioned, there were some awesome links that he shared. So we'll be sure to add that also in the description box if you're watching on YouTube. If you're watching on LinkedIn, we'll do the same thing in the comment section. Oh, sorry, the description also of the event. Is there anything else, I guess, any last words that you'd like to share with the people, Mr. Culver?
Um, Thank you for listening to me, Rebel. I see there were a bunch of other questions in the chat. If for some reason you have another question and we didn't get to it, feel free to connect with me on LinkedIn. I usually try to check my DMs at least like once every day or two.
We really
But
I love that.
I'm always happy to chat with folks. I set time aside every week just to talk, just because you don't really find a lot of data engineers, you don't find a lot of black data engineers, and you don't find we're not accessible. There's not a lot of us accessible for sure. So anytime I can chat with somebody and share my experience, maybe keep you from going down a bad path that I've gone down before, always happy to do that. So hit me up. I'm around.
I love that. And again, I'll just put the screenshot again of all of the ways that you can continue to connect with Anthony here on the screen. Go ahead and screenshot. I see a lot of love coming in the chat saying thank you. We see a lot of fire emojis as well. So thank you all. And again, we will be here tomorrow again with Michael Boone for product management. We look forward to seeing you same time, same place. Bye, everyone.
Bye.
Bye. Have a good one, y'all.